Hi, my name is Tianle Liu, and I'm here to do the probability course homework 1, problem 5. And for first, we have to view the problem first. We can see that there are two methods to do the blood test positive. And the first one is to do all the tests. So it's totally like 100 tests. But now we focus on the method 2. It divide 100 people into 10 groups, and for each group have 10 people. So now we know that there are 10 groups, and each group have 10 people. So it makes the blood for the 10 people into one test to test whether the blood is negative or positive. So then if the test is the positive, we will do one by one. If the test is negative, so means that the people in that group is all negative. So the most of the tests we need to do in one group is 11, and the least is 1. So there's only two possible choose tests of this method. So now we have to find the number of tests we need to do by the second method, which means we need to find the expected method for that, expected test for that method. So for now, we need to do, let me think. So we need to do two probabilities first. Oh, we need to assume n first. We assume n as the number of tests for each group. So now we can find the probability for the tests. So there are two possibilities. One is only use all negative tests, so only use one test for that group. That is, all the people has negative. And we see that from the problem, we see that the test result is positive equal 0.1. So, which means the negative test probability is 0.9. And since we have 10 people in each group, so the probability of all of them are negative is 0.9 is order of 10. And since it's a large number, I will use my TR Inspire. And we can see the answer is rounded up by 0.35, and the probability of n equals 11. So I think it's a tricky part of the problem that under what situation do we need to do the all tests for all the 10 people? That's just we need one or more positive test case in the blood, and when it mixes up, it will test as positive. In this case, it's a probability problem that it's just the complement of the all negative situation. That is not all negative. So for this problem, we only need to use 1 minus probability of n equals 1, which means they are all negative. So it will be rounded up by 0.65. Yeah, that's the probability of doing 11 tests for that group. And now we have two probabilities. we can calculate the expected number of tests for the whole group, for the whole group. That is 1 multiply probability of number of 1 plus 11 multiply probability of number of tests of 11. And we can see it's 0.65, 35 plus 11 multiplied by 0.65 is 7.15. And the answer is the 7.5. Yes. And but we need to focus that the problem asks us is what to do, how many tests of how many number of tests we need to do. By the second method, it means that the whole party of people, not just a group. So we need to we know that there are 10 groups now. So for this problem, the expect number of the all party test will be 10 multiplied 77.5, which is the expected numbers of each group. And it turns out to be 75. So this is the answer of the question. That's the expected number of tests we need to do using method 2. And obviously it's quite less than the method 1. So I think it's an efficient method. That's it. Thank you.